The world will really change when we work in a truly distributed manner.
The thing about it is the ability to take networking compute and data capabilities and everything that's required to do like interesting things around that is going to go from hundreds of locations to thousands of locations to tens of thousands of locations to hundreds of thousands of locations.
Ericsson's Jason Hoffman is walking us through his 7 concepts for a successful company. I'm Dodi Axelson, also with Ericsson, and I'm glad you joined this cloud conversation. We're on to the third word in this series, distributed.
When you build something very centralized, and this goes across all aspects, centralized development teams that are all working in the same office. A very centralized data architecture. A monolithic vertically integrated application that runs in 2 locations in a country. Those are straightforward to do. It's straightforward to put everybody in a room and have them hammer out, a box. When you start thinking about what's required for you not to care where your engineers live and work, it requires a certain communication structure to be able to do that, yet it's a much more complex, difficult thing to do. Distributed systems in computer science are they're more difficult to do than non-distributed systems. When you look at the stuff right now is we have a lot of very centralized infrastructure in the world. A good example is the large public clouds, where these are in a couple hundred locations in total across all of them. And they have a complete set of network compute and data capabilities there. As you move progressively out the infrastructure and closer to the device and the device themselves, well, there's billions of devices in the world, talking to tens of millions of base stations and so on like that. The devices, each individual device does something, but none of them collectively do things. The layers of infrastructure. So the thing about it is the ability to take networking compute and data capabilities and everything that's required to do interesting things around that is going to go from hundreds of locations to thousands of locations to tens of thousands of locations to hundreds of thousands of locations. If you think about things like just the desire to be within a millisecond of anywhere, and that's a millisecond round trip. So you have to actually be, really a couple hundred microseconds away from something in one direction and then a couple hundred microseconds in another direction, and you have to allow some things to sort of occur in there. So even if you want 1 millisecond round trip, the parts of it have to be in the hundreds of microseconds. If you want to cover the world with things that are within 100 microseconds of something, then you're talking about hundreds of thousands of locations. And it's not, by the way, it's not a difficult thing to calculate.
But why do you pick the word distributed instead of talking about the edge or computing at the edge?
Because the edge is like a thing, not what the thing is. So what is the edge inherently? It's very distributed. The problem is not something at the edge. Everyone's got a supercomputer in their pocket today called a smartphone. The problem is not the presence of that. The thing is how would you do things like have 1 million smartphones work together to do something? I mean, the only people that are basically taking advantage of a distributed system on top of devices today are basically botnets for criminal behavior. Mm-hmm. No, I mean, you know what I mean? Let's take 100,000 cameras inside of people's homes and use them as a botnet to DDoS somebody else.
Right.
Okay, so those guys have done that. Mm. But we're not using any of that for any productive work at all. Right? And it's
But we should, is what you're saying.
Yeah, of course. Yeah, of course. I mean, if you sit down and you say, our ambition is to have a very feature-complete edge that does the following 20 things to help mankind. Okay, well, the problem's not that you want to do the edge. The problem is that the edge is a very distributed system that now has to coordinate amongst itself and everything else like that. And as you can imagine, getting one person to do something is very different than getting 1 million people to do something or 100,000 people to do something. It's a different problem. No, I mean, think about it. Let's say you want to collect data from 1 million autonomous cars for the purposes of road safety, right? Okay, how? You're going to have a very distributed system that does it.
Right. So that's continuous improvement with autonomous vehicles and driving, and then ultimately
they all interplay with one another. So the stuff that you're going to put, the distributed system that you're going to put on the edge is going to require the interplay of hardware and software in a way that most systems we ship don't do. It's such an expensive stuff to put in place that it's going to have to be capable of continuously improving where it is and how it is, right? Meaning like, if you take the road example, I mean, as you can imagine, if you went and you made every road self-heating so there'd never be ice on a road, if you went and you did that, that'd be very expensive. And then once you did it, you wouldn't want to do it again, right? So you'd have to have a way of like continuously making that better where it is once it's there. And the idea that you're going to do it everywhere, be distributed, is hard.
Our next word will be data-centric. Think you can't relate? Think of it this way.
Road is a network, a car is compute, and your child in the back seat is your data.
Join me, Dodi Axelson, and Jason Hoffman for the next Cloud Conversation from Ericsson. Bye for now.